Hi friends, welcome back. Today we are going to solve one important coding challenge on Codewars, find the smallest. So before we start looking into these important coding problems, and we are going to talk about two different solutions to solve this problem in today's session. But before we start looking into the problem details, I want to mention that this channel is to help people in their coding and Java interviews. On this channel, you will find lots of helpful videos that you can use to prepare well for your coding as well as Java interviews. For example, there are more than 450 different varieties of coding problems solved and explained using whiteboarding session examples and Java code. Many of those problems are taken from previously asked coding interview questions by Google, Facebook, Amazon, Apple, Microsoft, Yahoo, and many other big companies. Among those solved coding problems, you will find all important coding questions varieties are covered in them. That includes breadth first search, depth first search, matrix problems, graph problems, binary search tree problems, coding questions related to linked list, strings, optimization problems. A lot of problems related to important data structures are also covered in that list. That includes queues, stacks, priority queues, hash table, hash set, hash map, tree set, tree map, and a lot of other important data structures. So if you are preparing for any coding rounds of interviews or Java rounds of interviews, this channel can definitely help you in your interview preparation process. So please subscribe to this channel now. Also, whenever we come across any important coding questions or coding challenges, we create videos to discuss more about the problems, the logic, the approach, and to discuss more about how to optimize different solutions so others people can also learn problem solving, Java programming, data structures and algorithms by watching these videos. So make sure you click on the bell notification icon so you won't miss any important upcoming videos on this channel. So let us start this important problem, find the smallest. You have a positive number n consisting of digits. You can do at most one operation. Choosing the index of a digit in the number, remove this digit at that index and insert it back to another or at the same place in the number in order to find smallest number you can get. Return the smallest number you can get. So this is what the challenge says, right? So now they have given us some examples. So let's take this first example here. So now in this example, let me just explain you. Let me choose a pen. So now here they have given us this input number, right? 1 2 3 6 4 5, right? So I'll just write down here. So 1 2 3 6 4 5 2, right? 6 4 5 2. So this is the input number that is given to us. Now we are basically allowed to remove any number and place it at any other position, but we can do it only one time, right? So for example, what I mean to say is we can just remove this 4 and I can put this 4 at the beginning, right? So if I put it at the beginning, the number will become like this, right? 3652, right? So if I remove it from here and if I put it in the beginning, this is how the number will become, right? So this operation is allowed. Basically we can do it, but now we have to find out the minimum possible number that we can make using that operation, right? So what I mean to say is we can remove this 2 from here and we can put it in the beginning. So if I do that, then it will give me 2136452, right? This number it will give me. Now this number is not smaller than this given number, right? So we cannot consider this number. Our goal is to find out the smallest number possible by doing this operation, correct? So when will we get the smallest number? If I delete this 2 and if I put this 2 here, right, then I'll get the smallest number. So what the number will be? 1223645, right? This is the smallest number we can get. So we have to output that number 1223645. So now as you have seen, so we have removed this 2 and we placed it here, but it means that the 3 and the other digits will move basically by one place, right? So 3645 moved by one place basically, right? So important to note that 3 did not get removed, it just got moved by one place on the right side, correct? So you are inserting it basically between 2 and 3. You are inserting this 2 between this 2 and 3 basically, correct? That's what you are doing basically, right? So this one operation is allowed. So now with this explanation you understood what the problem is, right? So we are allowed to remove any one digit from this. We can place it anywhere, but our goal is to minimize the number, right? Now another example, if we want to consider, let's take another example. Now let's say 99 88 and 12, let's say, right? This is another example. Now what number we will get if I take this one and if I put it at the beginning, right? So what number I'll get? 199882, right? So this is the number I'll get, and this is the minimum number I'll get. But now how will we solve this problem? So now you understood what the problem is. We have to find out the minimum number that we can make by using this operation that we are allowed to do, right? So basically in the first approach I'll show you two different solutions. In the first way we will do a brute force approach. So what brute force approach does is we will try to create all the possible numbers basically, right? So what does it mean by all the possible numbers? I'll tell you that. So now let's say we have a number. Let's say our number is 4 3 2 and 1, correct? This is our number, let's say given number. So what we will do is we will do all the possible combinations. What I mean to say is we will remove this one and we'll put it at the beginning, right? Or basically we'll start with 4, right? So 4 we'll remove it from here. I'll put it in the in between 3 and 2, then I'll put it in between 2 and 1, then I'll put it after 1, right? So these are all possible things I can do. For example, I take this is one number given. Now I'll remove this 4, I'll put it between 3 and 2, right? So what it will give me? 3412, 3421, sorry, 3421 it will give me, right? If I put it here, what it will give me? 3241, right? 3241 it will give me. If I put it here, then what it will give me? 3214, right? 3214. So I will try to put it at all the possible places, this number, right? I'll try to put it at all the possible places, and I will keep track of the minimum number I have seen, correct? Now after I have done that, I will use this number next time, right? This number also I will try to put it on in all the possible places. How I will put it? Like next time 321 4321 is given, so I'll remove this, I'll put it in the beginning. So what I'll get? 3421, right? This is what I'll get. If I put it in after 2, then I'll get 4231, correct? I'll put it here, then I'll put it at the end. What I'll get if I put it on the end? 4213, right? So basically I am this is a brute force approach, right? What this approach is called as a brute force approach if you are a new developer, right? Why brute force? Because this is the most basic approach we can use to solve this problem. So we are trying all the possible combinations, correct? So I will remove 4, I'll try to put it in all other places, and I'll keep track of the minimum number I have seen. Same thing I will do it for 3, then I will do it for 2, then I'll do it for 1, right? And ultimately if I do it all for all the numbers, then I am going to find out the minimum one, right? Because I am keeping track of the minimum number I have seen. So this is the most basic way. So this is our first solution. So how it will look like, I'll show you here. So this is how it looks like, right? So if number is given to us is 1236452, then 1 will be here first, then I will put 1 here, right? Then I will put 1 here. See how I am putting everywhere this 1, right? Every possible place. Then 1 here, then 1 here, and then 1 here, correct? So now all the possible places I have put this 1 basically, correct? I put it here, then I will put it here, then I'll put it here, 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 and here, right? All the possible places. After I am done with 1, I will start doing the same thing with 2, right? How I will do it with 2? Here, right? I'll put 2 here, then I'll put 2 here, then 2 here, right? Then 2 here, here, and here, and here, right? So this is all the possible places I can put 2. Once I am done with 2, I'll do the same thing with 3, right? So here 3 again. I'll not like I have to move this to show you the whole thing. let me see if I can move this thing. So I think you got the idea, right? So we are going to do it for all the possible characters. We'll put it every possible places, right? And we will keep track of the minimum number we have seen, correct? And what we will get minimum number here, number will get minimum 1 to 2 3 6 4 5, right? This is the minimum number we'll get. This 2 we will put it here basically after this 2, right? That is will give us the minimum number, right? So this is our brute force approach. The problem with this approach is we will have two for loops, so the approach will run in n square, right, time complexity. And this is the problem with the approach. It will solve the problem, but if this number is big, then it will run slow, right? So let us go first take a look at the solution, then we will discuss how to optimize this approach, right? So this is our brute force approach. So find smallest is the class. Smallest is going to return a long, and we are going to get an input as a long number, right? And we have to return the smallest number by doing the one operation that I mentioned you. So we will create a variable min is equal to n in the beginning, correct? The number we will just convert this n into string, right? After that we will run these two for loops, right? I is from 0 to number dot length and j is also from 0 to number dot length, right? Then what we will do here is we will pass this number and we will pass I and j. So we always try to get a new number with all the possible combinations, correct? All the possible combinations we are doing here because of this for loop, right? This make new number, it's actually what it does is, this is another helper method. So it just uses I and j indexes. So see just how it is implemented. String builder, and we created a new string builder from string s, right? Then we are reading the character at the ith position, and we are deleting the character at the ith position here, right, from the string builder, and we are inserting the new character j into the into the jth position. This character that we have removed, we are inserting it at the jth position, correct? So this is what basically what we are doing there is, let's say we have let's say 1 2 3 4, let's say, right, for example, right, if this is your j and this is your I, then we are actually deleting these three and we are inserting it here. So it will after 1, so it will become 1 3 2 4. This is what we are doing. So we are inserting it after 1, correct? That's what we are implementing it here, right? So we'll just use string builder because string builder is easy to manipulate, right? You can just delete a character at specific index and you can insert a character at a specific index, correct? So we will just do the one operation on that string. We will convert that string builder into long, correct? So we are basically getting all these numbers. So what I showed you here, these ones we are getting, right? So we are let me just remove this color so we can reuse this space. So we are, let's say, at 1, correct? We are at 1. So we will actually start replacing that 1 here, then here, then here, all these places basically, right, wherever it is possible. Now this is the end, right? This is the end because we have actually put this 1 in all possible places, in the beginning, then between 2 and 3, between 3 and 6, between 6 and 4, 4 and 5, 5 and 2, and after 2. So we put this one every possible place here now, right? So this is exactly what we are implementing here in this make new number, right? This is the same thing we are doing here. And because so we get a new number, we always keep track of if I should not be equal to j basically, right? Because we don't want to replace the number at the same location, right? Then it won't give us any different number, right? And new number should be less than the minimum that we have seen so far, correct? Then we will want to update our minimum. If the new number is lesser than our minimum, it means that that is the smaller number, so we want to update the minimum, and at the end we will just return our minimum number we have seen by doing the one operation that we are allowed to do, correct? So this is our first approach. This is the brute force approach. As you can see, it runs two for loops nested, right? This is nested for loop. So it means that its time complexity will be order of n square because of these two for loops. It means that this solution will not be accepted mostly in the interviews, right? N square solution is not accepted in the interviews. So we have to find out a little better solution, but this is the basic solution that you should understand, and as a fresher or as a junior level developer, you should know what the brute force solution should be, right, to solve these kind of problems. And then once you understand brute force solution, then we can optimize this solution now, correct? So I hope this brute force solution you completely understand now. So clear, right? So this one brute force. So one we have done one. Then what we will do, same thing we will do it for two, right? We will put two here, then two here, then two here, then here and after two, right? All these places. And that is what exactly we are doing here, right? We put two here, then two here, two here, two here, two here, two here and two here, right? So here we will end basically. So now you understood this brute force approach. So now I will show you another better way to do this code. Now the main problem with that brute force approach is that it runs in n square time complexity. So now let us try to do it in little better time complexity. So how we can do it? So to get the minimum number, you must have realized that what we have done is we have chosen these two and we put this two after this two, correct? And then it gave us minimum number, correct? So it means that what we can do to solve this problem is we will first go through all these numbers, right? 1, 2, 3, 6, 4, 5, 2. We will add it into a list, all these numbers, and we will sort the list, right? We will do the sorting, sort the list. So what the sorting will give us? So the sorted list will give us like this: 1, 2, 2, 3, 4, 5, 6. Correct? This is our sorted list, right? 5, 6. Now we got the sorted list. Sorting will take n log n time, right? The time complexity for sorting is n log n. If you use collections.sort or arrays.sort, right? Anyway, it will take n log n time. So now this once sorting is done, what we will do is we will go through, we will create one pointer which will point to this location, right? It will point here in the beginning, this pointer, and our another pointer will point to here basically, correct? So we will check if this sorted number, if this number should we replace it here basically? Is it beneficial if we replace it here? So 1 and 1 are same, so there is no point we should replace it, right? So it means that we should not replace it basically, right? Then we will go to the next position. So we'll move this pointer here. This pointer also goes to the next position, correct? Here. Now again we check if can we replace this 2 with this 2. There is no point of replacing, right? Because both are same. So it means that there is no point of replacement. So it means that we should go to the next position. So we'll go here and pointer will go here, correct? Now should we replace this 3 with this 2? Yes, we should replace it, right? Why? Because it is going to give us a smaller number now. So now what number we will get? We will get 1 to 2, right? And then we are actually replacing, means basically what we are doing is we are taking this from here and we are actually putting it in between 2 and 3. So it will give me 1 to 2, 3, 6, 4, 5, right? 3, 6, 4, 5. So now if I do this, then I am going to get a smallest number that I can be by using this one operation that we are allowed to do, right? Why? Because these numbers are sorted in ascending order. So we know that we have this number which is available in this one, right? And we can put it here basically, correct? So I hope you understanding this logic, right? This is very important logic to understand to solve this problem. So we know that 2 appears 2 times in this one, right? And definitely it is possible that I can remove it from here and I can put it here after 2, basically after 2 here, right? So if I put it after 2, then what number I'll get? I'll get 1, 2, 2, 3, 6, 4, 5, right? And that is going to give me the smallest number which is possible. So if I do that, then I have solved the problem in n log n time, which is much better than n square basically now, right? this is much better than n square, correct? So we have used sorting and we have just used some simple logic that I explained you, that will create the pointers, and then we will have to just find out a place where we should put these two, correct? And also one thing, when we are implementing this sorting based solution, is we have to always check if the given number already is a sorted order. For example, if the input number is like 1 2 3 4, then we cannot make it smaller than this basically, right? This is already the smallest number. So it means that we have to make sure that the number is already, if it is already following a sorted order, we will just return that same number, because there is nothing to do there basically, it's already the smallest number, right? So that one check we have to do basically, correct? When we are implementing the sorting based solution, right? So now I think this approach is clear to you. So now we can just go ahead and once we look at the code, then it will be clear to you. It is a little bit uh, more involved in implementation, but it is a better approach once you consider the time complexity of the code, right? It's much better than the brute force approach. So this approach should be like accepted. So I'll show you the another approach, which is the same approach that I just explained you. So now again we have a smallest function. We are going to take a long n here, right? And we are going to return a long number, right? So now we will have a minimum which is same as our n in the beginning. We are going to create a couple of variables here. One is index1, index2, new number, and one is we will convert this n into a string number, and we will create a list of which is an array list of integer array. Why do we need integer array? Because in this integer array we are going to store two things. At the 0th index I will create the actual digit, right? The digit I will create, store. For example, if you look at this, I will store 1 there, right? 1 2 3 in that position. 0th position I will store the let me remove all these colors. There's too many colors. So what I will do in that list is I am going to store two things there. One is the digit, right? And one is its index. So let's write digit for D and index I for index, right? So for example, 1 2 3 6 4 5 2, right? 4 5 2. So let's say this is my list, right? And I will also have a corresponding index of that 0 1 2 3 4 5 6. So I know what the digit is, I know where that digit is. Two things, correct? So now that is why I am using integer array here. So now I'll go through the given number. I will create the list, right? So that I'll know the digit, I'll know the index basically in that list. Now first thing I wanted to do here is, before I start proceeding with my other solution, I wanted to check if this given number or this list is sorted already, right? If it is already sorted list, then it means that we will directly return that n, because n cannot be, n is already minimum in that case. For example, what I mean to say is, for example, 1 2 3 4, right? It is already sorted, so we will directly return it basically, right? So this is what we will check first. Now if it is not already sorted, then we will have to sort the list, correct? This list we will sort, right? How we will sort this list? Based on the digits, right? So if I sort the list, what I should get here is I'll get the like this list basically, right? Sorted list I'll get 1 2 2 3 4 5 6. Obviously there I will also have the indexes that I will not show you here, but this is the sorted based on the digits, correct? So now I am going to sort it, and when I'm sorting I am using x0 minus y0, which means that I am using the digits actually, right? Not indexes, I am using digits, correct? So now we have the sorted list. Now we will just create a pointer and we will go through the number, we will go through the number, right? And we will check if the we'll get the current number, right? Current number, and we will check if the current is greater than the list dot get pointer 0, means checking if this position is good for adding small number, right? So exactly what I explained you here, right? So let me just remove this now. So you understood how to create that list. So now exactly what I explained you we are doing there. What we are doing, we will have two pointers. One is here, one is here, right? And I will check if is it worth to replace this one with this one. No, it's not, right? Because both are same. Then I'll move the pointer next time here and here, right? Again I'll check if is it worth to replace it. No, then I'll move it again next here, right? Again I'll check if is it worth to replace it. Yes, because it will give me smaller number now if I replace, right? So when I replace, then it means that obviously I am going to use this 2 basically. So this 2 will be gone because I know the index of this 2. I have stored it in the list, right? I know the index, correct? So once I replace it, once I add it between this, like here, right? 2, 3, 6, 4, 5, right? 4, 5. So this 2 I have added it and I know from where I took it, right? So I will not add it into when I create this number, right? Because I am using this 2 here, right? So that's how I will know that I don't have to use, like, take this 2 because I'm using it here, right? So this is what we will implement here, right? So now if we find out the position now where we can actually do the replacement, we'll capture the index of that position, we will capture the new number, right? And we will also capture the index 2 which is stored in the list, right? Because these all information we will need basically to create the new number now, right? For example, once I find out yes I can do this replacement, I'll need this index, right? Where I want to do the replacement, I'll need the index of these two also, correct? Where this information I am just gathering here, right? And I am just going to break out. Once I have this information now, I'll break out from this for loop and I'll go here and I'll create the actual number with this information, right? The make number takes this index 1, index 2 and new number, right? And it will give me the new minimum number basically, right? So this make number method, we are actually, as I explained you here, so one more time I'll explain you, because this, as I said, this solution is little bit more involved in the implementation, but you understand the logic, then it's not very difficult. So we know that this is the place where we want to put and what number we want to put to, and we know the index. For example, this index is 0, 1, 2, 3, 4, 5, 6, right? 5, 6. So these are the indexes, right? So for this two, the index is 6 basically, correct? This is the 6, this index is 0, this index is 1, correct? So now I know that I want to actually put this uh, 2 from index 6 and I want to put it at this location, correct? So I will just go through this 1 2. After that I know I need to put this 2 here, so I'll put the 2 there, right? And I will have to move this 3 6 4 5 basically. 3 6 4 5 will be moved like this, and I will not append this 2 basically, right? Because I have already used this 2 here. So this is exactly what I am implementing inside this make number method. So I am creating a list of characters here. I'm going to go through this string s and I'm going to add all the characters into the list, right? And then I am adding the index 1 here, right? Index 1, and I am adding the j. J means the new number, the new character. So the new character in the sense is 2 instead of 3. I know that I want to put 2, that 2 is the j basically here, right? 2 is the j. So I will add that 2 in this list. After that I'll create a string builder. I will again go through the string s here in this for loop, and whenever I will have to keep appending the list x, right? List dot get x I will do if it is not equal to, x is not equal to index 2 plus 1, then only I will append it basically, correct? So what I just explained you exactly what we are doing. So I will take this 1 2, first 1 2, then I know I want to replace this 3 with this 2, right? Then I'll put this 2 here, and then this remaining 3 6 4 5 I will add it. This 2, when I reach here, I know that I already used it because I know the index here, right? I know the index, so I know that I already used this 2, so I will not append it basically, right? To the string builder, we are doing it these things in a string builder, right? String builder, we are building a dynamic string here, correct? And then we'll just convert this string builder into a long, correct? We are just converting the string builder into long here, right? So that's it. Basically this is the whole implementation. This check if sorted method is actually takes a list and it checks if this list is already sorted or not, right? So this is what it is checking, because if the number is already sorted, then we don't have to do anything in that case. So that's why I just created one this helper method check if sorted. So this is all about the implementation for this approach. Now as you can see, there are no uh, basically nested for loops here basically, right? So here this is much better solution than the previous solution. So let us just go ahead and let us execute this code snippet with some examples. So this is the example. We'll just test with some examples. So now as you can see, we are testing this example. I'll just make it big so you can easily read this. So 1 2 3 6 4 5 2, so we are actually putting this 2 here, right? So 1 2 2 3 6 4 5, 1 2 2 3 6 4 5, which is the correct answer. So let us this is the same example I just discussed. So now this is another example, 1 1 4 4 8 8 2. So we will remove this 2 and we will put it after this 1, right? So let us make sure it works. So as you can see, we are getting correct answer 1 1, then we put 2 and then 4 4 8 8, right? So we are getting correct answer. Let's go ahead and take some other examples. So this one is 998833112. So now we will take this one and we will put it in the beginning, right? So that one will give us the smallest number. So let's make sure it works. So we have put that one in the beginning, then we have 99883312, right? 998833, and one we already removed, so 12, correct? So correct answer. Then we can, I'll show you when the number is already sorted, then we don't have to do anything. This is already the smallest number, right? So we will get 1 2 3 4 in this case, which is the correct answer. So this is the way we can solve this problem, find smallest. One of the Codewars challenge. I thought it's worthwhile to create a video and show you two different approaches. One is the brute force and other is the improvement in the brute force approach that I shown you. That we have used sorting, right? And then we have also used a little bit of a string builder here to create a dynamic string, right? So I hope you completely understood both of these approaches in today's session. If you are new to this channel and if you haven't already checked the very important playlist on this channel, there is a very important playlist on this channel. The name of that playlist is Leetcode and Leetcode Solutions. That playlist has more than 250 different varieties of coding problems solved and explained there. Many of those questions are asked by Google, Facebook, Amazon, Apple, Microsoft, Yahoo, and many other big companies. And many are frequently asked coding interview questions, very important questions. So if you are preparing for any coding rounds of interviews or Java rounds of interviews, this is a kind of a very important playlist you should go through. You are going to learn a lot there, more about data structures, algorithms, problem solving, logic building, implementing different Java solutions, and how to use different important Java classes to implement different complicated approaches, right? So you will learn a lot there. Check out those playlists. I'll repeat the name. The name is Leetcode and Leetcode Solutions. Apart from that, if you are looking for more coding problems for your practice, then there are three other major playlists on this channel available. The names are Codeforces, CodeChef, and AdCoder. All in all, there are more than 450 different varieties of coding problems solved and explained with examples. All the problems come with Java solution code, where the Java code is shared through GitHub repository. You will always find out the link to the code in the video descriptions, where you can go check out the code, play with the code with by creating your own input different test cases, so that you can understand the code better. If you go through those videos, you will also learn a lot about how to implement complicated approaches using Java, and what are the important Java APIs and Java classes that can help us implementing complicated problems, right? So check out those videos, you will learn a lot. If you like this video, if you find this video helpful, and if you learn how to solve this find the smallest problem with two different approaches, and you like the video the way it's created with examples and explanation, then please give it a thumbs up to the video, give it a like to the video, subscribe to this channel. Your subscription is very important for the channel, because that is the way the videos can reach to more people who need help in solving coding problems. Some people find it difficult to solve coding problems. Through this channel, we would like to help them by showing them how different coding problems can be solved using different data structures, algorithmic techniques, and using Java programming language. So they can also learn programming, problem solving, logic building by watching these videos and looking at these videos. Uh, you will learn a lot by watching these videos uh, about Java programming, data structures, and algorithms, and they will also definitely help you in your coding interviews, as well as in your in-person interviews. If you like the videos on this channel, if the videos on this channel are helping your learning process, you are learning something new, hear more about data structures, algorithms, problem solving, logic building, then please do comments on these videos and tell us about it, how the videos are helpful to you. Your comments are very important to us. That increases our motivation to create more such good quality content. So if the videos are helpful to you in your learning process and your coding interview preparation process, then don't forget to leave the comments. If you want us to create a video related to any particular topic about computer programming or Java programming language, then also leave that into the comments. Keep coding, keep practicing, keep solving different varieties of problems, and thanks for watching this video.